Welcome viewers to this session of today. We want to conclude on the part remaining on fractions, then later we will start on decimals. And the last thing in fractions we are going to do is number sequence. This number sequence we are talking about is in fractions. We had done number sequence previously, but that was on whole numbers. So today we want to do number sequence in fractions, and by now you should be able to know what a sequence is. And we said that a sequence may be numbers written following a certain or a specific order. Then apart from sequence, we have to understand the order. These two things are the basic about number sequence. We call it order of sequence. This order is what is enabling us to move from one term of the sequence to the next. So by determining the order of the sequence, then we can complete the sequence itself. So sequence in fraction will obviously involve fractions. If it is a whole number, if a whole number has to be there, then you'll find that it is in form of mixed fraction. So I'll just move forward to do an example which I have here. Example that is 1. What is the next number in the sequence? What is the next number in the sequence? And the sequence is given below as follows. We have a quarter, we have 1 over 9, then we move to 1 over 16, then 1 over 25, and then there is a blank space for the next number. This is the sequence we have, and we cannot move to fill the blank space when we don't know the order. We must check through whatever we are given in the first part of the sequence to know the order they are using to get to the next term. We can see that all the numerators are 1, 1, 1, 1. Probably the next one will also be 1. But when we come to the denominator, we can see a changing pattern. We are moving from 4 to 9 to 16 to 25. A quarter, a ninth, 1 over 16, 1 over 25. We can see that the denominator has a following pattern. And the pattern in the denominator from 4 to 9 to 16 to 25, you can see that they are square numbers. Square numbers. 4 is a square number, 9 up to 25. So it means for us to find the next number, the order they are using, the denominator are square numbers. It means in the next term or the next number of the sequence, the denominator must be the square number after 25. After 25, the square number is 36. So we will have 36 as the next denominator. But on the numerator part, we can see 1 is consistent in all. So we will have 1 over 36. This 36 conforms to the order of the denominators, the square numbers, but 1 is consistent in all. So our next number here will be 1 over 36. Another one we may do, find the next number in the sequence. And the sequence we are given is 27 and a quarter. Then we have 24, 1 over 9. We have 22, 1 over 16, and 19, 1 over 25. Then we need the next. So we are given the sequence. The basic thing is to determine the order. When you know the order, we will do it to the last number here to get the next one. Now, this one is comprising of all numbers and a fraction. That is the mixed fraction type. Here, we will have to check on the all numbers what is happening to the all numbers. Then later, we will see on the fractions, because we can see the fractions we are given are like in the first sequence where we have a quarter, 1 over 9, 1 over 16, 1 over 25. That is the repeating pattern here. We have 1 over 4, 1 over 9, 1 over 16, 1 over 25. But the all numbers from 27 to 24, we are subtracting 3. Then 24 to 22, we are subtracting 2. Then again from 22 to 19, we are supposed to subtract 3. So we can see the pattern down here for the whole numbers. We are reducing by 3 first, then 2, then 3 again. Possibly the next one should be able to reduce by 2, because that is the pattern. We first reduce by 3, then 2, and it is alternating. When you come from 3, you go to 2, you move to 3 again, you go to 2, 3, 2. So the pattern is alternating. Reducing by 3 first, then 2, then 3 again, then 2. So that one is whatever we are going to use to get the next whole number after 19. So we will have 19 minus 2. That will be 17. We are through with the whole number part of these fractions. Now come to this fraction part. We have a quarter, 1 over 9, 1 over 16, 1 over 25. As we had done before in this first sequence, we know that after 1 over 25, the next one should be 1 over 36. So we will have 1 over 36. The next number of our sequence is 17, whole number, and 1 over 36. After doing that, you can now gauge yourself if you can determine the rule in this sequence thing. We have, let me say it is an exercise. We have 1 1/4. We have 2. Then 2 3/4. Then we have 3 1/2. After 3 1/2, you have 4 1/4. Then there is that blank space. So you are supposed to find the next number of the pattern. Another one I can give is we have 1 1/3, 1 1/3. Then we have 2 2/3. Then we have 5 1/3 and 5 1/3. Then 10 2/3. So that is the sequence we are given. So you are supposed to find the next number after 10 2/3. 1 1/3, 2 1/3, 2 2/3, 5 1/3, 10 2/3. So there must be an order they are using to get the next number. Determine that order from this and find the next number. Up to there, we are through with the fractions, and I'll just like to move to decimals straight away. And in decimals, it follows the pattern of all numbers, where we are going to start with place values and total values, and we will check on conversion. We can convert them to fractions and many other things. So whatever we are starting on now is decimals. And I've said we start with the place value. place value of decimal. We said a place value is the position of a digit in a number. The position of a digit in a number, where the digit is located. That is now its place value. And previously, we had used what we call a place value table. Place value table is just a method. It is an easy way so that you are not confused. It is a place value table. This is a place value table. You can draw it bigger so that the questions, when you have around 5 questions, you can just fix them there. And I'm going to draw one so that you may see. Always, we will have that part of decimal. Because this is now our main concern. After the decimal point, always represented by a dot, we are now going to move to tenths. Not once, it doesn't exist. We start from tenths after the decimal point. Then we move to hundreds. Then thousands. Always the place values of decimals, the word ends with this sound. Tenths, hundreds, thousands, and it continues. On this side of the decimal point, now that is the whole number part, we will have ones as normal, then tens, hundreds, we will have thousands, 10,000, then we will have 100,000 as we move to a million. So this is the way it is. This is now the place value table, but we are now including the decimal point. That is the basic thing here, because we are now dealing with the decimals, not all numbers. So if I may give examples of some values here, we can say that write the place values of the digits in the numbers below. Write the place values of the digits in the numbers below. The numbers we have, number 1 is 0.15. Then we have number 2, 27.351, and the third one we have 156.704. You will notice that I'm saying 0.15, not 0.15. Decimals, we always say the digits as they are, not as numbers. We say that we name the digits 27.351, not 27.351. We say the digits. So we will have our decimal point here, and then we now start fixing the values. We have 0.15. To the right side, to the left hand side, we have 0, then a decimal point. So if we have a decimal point here, we will have 0 because it is the first value to the left. It means 0 is a whole number occupying the place of ones. Then we will have 1 on tenths place value and 5 on hundreds place value. Then we will move to do the second one, that is 27.351. 27.351. From the decimal point to the left, we have 7, then 2. Then from the decimal point to the right, we have 3, 5, 1. So we can see that the place value of digit 3 in the number is tenths. The place value of digit 5 is hundreds. Then the place value of 1 in the number is thousands. We can go forward to do number 3. That is 156.704. To the left, we have 6 first. Then we have 5 and 1. Then to the right, we have 7, 0, 4. So this is an illustration of how you can do place values of decimals in a place value table. When you use this table, it is always simple to do, because when you have table once, you can now just go ahead and fix the values on it. Here, you can still continue down when you have other numbers. So that is all about place value. And after place value, we will go to total value. And the total value of a digit in a number is now the product. Total value. Total value of a digit in a number is the product of the digit and its place value. Now, in this table, when we now want to write the total values of these columns, tenths, we will have 0.1. This one now becomes the total value of tenths. Then hundreds will be 0.01. Then thousands will be 0.001. For tenths, you will have 1 over 10. For hundreds, you will have 1 over 100. But this one is written in a fraction. So when we are going to do conversion of decimals or fractions to decimal, then you will see that we can use this to write this. So when it is maybe 10 thousandths, then you will have 1 over 10,000. This one is going to give you 0.0001. Yeah, 3 zeros, then 1. This one is the total value of 10 thousandths. So when we talk of a total value, we will take the place value times the digit. Let us see in examples. We have example. And our example says, write down the total value of each digit in. Write down the total value. Let it be values, total values of each digit. And the number given is 3.5267. We need to write the total value of each digit in this number. And we've said that a total value, we will take a digit and multiply by its place value. When we have the decimal point here, this way we start from tenths. But going this way, since they are all numbers, we will start from 1. So when I do it down here, we will have the total value of 3 as 3 times 1. This one is for the place value ones. 3 is the first whole number to the left of the decimal point, so it occupies the place of ones. 3 times 1 is going to give us 3. Then the decimal point. So after the decimal point, I've said we start from tenths, and tenths is 1 over 10. That is going to give us 0.1. So we will take 5, which is occupying that place value. 5 times 0.1. That one is going to give us 0.5. So the total value of digit 5 in the number is 0.5. When we move to 2, we will multiply 2 by, because 2 is occupying the place value of hundreds, so we will have 0.01. When we multiply this, we are going to get 0.02. This one now becomes the total value of digit 2. We move to 6. We will multiply 6 by 0.001. It is occupying the place value of thousandths. The total value here will be 0.006. And lastly, 7. We will multiply 7 by 0.0001. When we do that, we are getting the total value of digit 7 as 0.0007. Up to there, these ones now becomes the total values of the digits in the number. Always remember that from the decimal point to the right, we are starting from tenths, not ones, because it doesn't exist. So when you understand that, you can try yourself with other values. Like if we have a number like, let's say 4.85, the first one, then the second one 7.009, and maybe the third one, we will have 12.205. You can try the 3 to gauge yourself if you understand. Always remember this, that the number of decimal places here increases as we move to the far end of the right hand side, from 1 to 0.1, 0.01, 0.00. So it keeps on increasing. It means from here we will have 4 zeros, then 1. Downwards it increases that way. So after doing place value and total value, we are going to look at conversion of fractions to decimals and decimals to fractions. So what we are going to do first will be conversion of fraction to decimals. We start with fractions to decimal, then we will check on the other way around. We have conversion of fractions to decimals. How do we do it? When we convert fractions, like we have 1 over 4. This one is a fraction. When we convert a fraction, when we have to convert a fraction to a decimal, this is what we do. We will divide the numerator by the denominator. In simple terms, we can say that numerator is the dividend. Then the denominator is the divisor. It may be simple for other people when we do it that way. So we will take the numerator and divide it by the denominator. So for us to convert a quarter to decimal, we will have it this way. 1, which is the numerator, the dividend inside the symbol. Then 4, which is the denominator, it is the divisor. So we will do this long division, and whatever we are getting there, be sure it is going to be a decimal. So 4 into 1, it cannot go there, so we will write 0 and a decimal point. Once we have that decimal point, we will be able to add 0 to the right of the number that we have, so that we ask ourselves, how many times does 4 goes to 10? That will be 2, which is 8. Okay, now here, when you have it that way, you will do subtraction so that you get the difference. That is 2. But since we have a decimal point here, we will keep on adding zeros to the differences that we are going to get. So that 4 into 20, that is 5 times. So when we convert a quarter to decimal point, it is 0.25. In this case, we can see that we are getting a number that is going to completion. After 5, we are reaching 0. But you'll find others that doesn't complete or doesn't reach 0. They keep on going down. So when we have that which does not repeat itself, we will call it terminating decimal. Terminating decimal. It is a kind of a decimal where we are reaching at a point that the difference we are getting there becomes 0. The other one, as you can see, when we do this, when we convert 7/11 to decimal, we can do the conversion. We'll have 7 then divided by 11, because I said the numerator is the dividend and the denominator is the divisor. So when we do this, we will find 0 point, then we add there 11 into 70, that is 6, giving us 66. The difference there is 4, but we have a decimal point there, so we add 0 to make it 40. Then 11 into 40 is 3, that is 33. When we get the difference here, we are back to 7. But remember, we have a decimal point there, so we will keep on adding 0 to the difference. So here, we will have 6 again, which is 66. The difference remains 4. Then, when we do it that way, we will add 0 to 40. It is thrice, that is 33. The difference again becomes 7. When we have 7, we add 0. So you can see that this step and this step are the same. It means when we keep on dividing, here will be 6. So we can see that in this one, we are coming from 0.6 to 3, then 6 again, 3 again, then 6. So digit 6 and 3 keeps on repeating. That kind of a decimal, we say it is called recurring decimal. Recurring decimal. Always you'll find that the digits, maybe not all, but 1 or 2 of them keeps on repeating themselves as you carry on the division. So you can see that at this point, the difference is never coming to 0. It will be a number that makes you continue dividing. Unlike in this case where we are reaching 0 so that it stops, this one doesn't go to 0. We call it a recurring decimal. So we have two types of decimals. We have terminating decimal, where we are coming to a 0 difference. Then the recurring decimal, where the difference never comes to 0. It keeps on, the numbers convert 3/5 to decimal. We want to convert 3 over 5 to decimal, and we've said that the numerator becomes the dividend and the divisor is the denominator. So we'll have 5 outside. 5 into 3 into 36. When you get the difference, it is 0, 0. You can answer that for yourself, which type of decimal it is when we get 0.6 that way, which type of decimal it is. We will move forward to check on conversion of decimals to fractions. We want to now convert it the other way around. We are given decimals and then we convert to fractions. We will start with the simplest. We are doing conversion of decimal to fraction. Let's take an example of 0.5. 0.5. When we did total value of decimals, we saw that we arrived to the total value by dividing 1 and the place value. If we are at tenths, we do it this way. 1 over 10, so that whatever you are getting is 0.1. 1 decimal place is a division by 10. 2 decimal place is division by 100. 3 decimal places are division by 1000. So when we are to convert decimals to fraction, we will count the number of decimal points it has. Like in this case, we are having 1 decimal point. 1 decimal point is as a result of division by 10. So we will have 0.5, let me do it here, 0.5 over 10. When you divide 0.5 by 10, you are going to get 5 whole number. As in the case of 1 divided by 10, you are getting 0.1. 0.5 divided by 10 comes to 1. If we can do other examples, we have 1.05 to be converted to a fraction. It is a decimal, 1.05. So here we have 2 decimal places. 2 decimal places, it is as a result of division by 100. So we will divide this number by 100. When we do so, we are going to get 105 over 100. When you have 105, then you divide by 100. This one will move the decimal point there. Then this 0 brings it here. So 1.05, sorry, is as a result of 105 divided by 100. That is what I'm writing here. So when we have 105 divided by 100, we can decide to leave it this way, but that is not appropriate. You may go further to simplify. We had done simplification of fractions, so here you can do it. When we divide through by 5, we are getting 21 on top and 20 as the numerator. When we have 21 over 20, I said this one is an improper fraction. So the best thing we can do to it is to make it a mixed fraction. 21 over 20 is the same as one whole number and 1 over 20, because when you multiply the denominator by the whole number, then add the numerator over the denominator, we are getting this. So this one is the mixed fraction form of 21 over 20. This is how we convert decimals to fraction. You just count the number of decimals. When you have 0.64, it has 2 decimal places. This one is the same as 64 over 100. So from 64 over 100, we can move further to simplify it. Let us divide by 4. When we divide by 4, we are going to get 16 over 20. 16 over 20 can still be divided further. 4 again, we will have 4 over 5. So 0.64 to decimals is giving us 4 over 5. Up to that point, you can find exercise from the revision books. You try on. If you meet a problem, always connect to us through the comment section. And thank you very much for the lesson of today. So when we meet next, we will be doing rounding off of decimals as we continue. Please subscribe to our channel so that you may also assist us when we are teaching at home. So when you view, you subscribe to us, you get more lessons and it continues. Thank you very much for now.